Drones are now believed to be involved in more than 80% of the attacks, causing Russian losses on the battlefield in Ukraine. And that number is beginning to change the way modern war operates. Across many parts of the front line, a Russian tank can survive artillery fire, cross minefields, and continue fighting because its heavy armor still protects the crew. But if that same vehicle is spotted by a reconnaissance UAV for just a few extra seconds, the entire situation can change before the crew even understands what is happening. What is even more dangerous is that these attacks are no longer isolated strikes. One drone can strip away the outer protective armor. The next drone can immobilize the target. A third drone can hit the exact weak point that has just been exposed. And above the battlefield, reconnaissance UAVs continue tracking the area, ready to guide more FPV drones, bomber drones, or heavier firepower toward anything that is still moving. That is why the war in Ukraine is no longer only a story about drones destroying tanks. It is becoming a story about how constant surveillance, precision strikes, and layered kill chains are changing the entire logic of survival on the modern battlefield. So how is Ukraine turning small drones into a hunting system capable of threatening tanks, radar systems, air defenses, electronic warfare units, and even Russian logistics? And why have current counter-drone measures still failed to completely stop that pressure? Let's find out with military force. Ukraine is turning FPV drones and bomber drones into a precise layer of battlefield firepower. And this layer is now reaching far beyond the trench line. Tanks, armored vehicles, radar stations, air defense systems, and logistics routes are all being watched from above, then attacked when their movement creates the right opening. These drones do not need the destructive force of a missile to change the battle. They need the right angle, the right timing, and a target that has already been tracked long enough to expose a weakness. This is why FPV drones have become so dangerous across several fronts. A small warhead may look limited on paper, but the drone carrying it can fly in ways that artillery shells and anti-tank missiles cannot. It can approach from behind a tree line, dive from above, turn around a shelter, or chase a vehicle as it tries to escape. That flexibility gives the operator a chance to hit places that heavier weapons often miss, especially when Russian vehicles are moving, hiding, or firing from cover. Reconnaissance UAVs are the starting point of this system. They watch roads, tree lines, firing positions, temporary shelters, and rear area routes, then turn movement into targeting information. Once a Russian vehicle is spotted, the battlefield no longer looks like open ground. It becomes a tracked and constantly monitored space above the battlefield. The most important moment often comes when the target loses speed. A tank turning toward cover, an armored vehicle slowing near a road, or a truck trying to separate from a convoy can create the short window that a drone pilot needs. In that moment, the strike is not about raw power. It is about placing a small explosive charge exactly where it can cause the greatest effect. This accuracy gives small drones tactical weight. A single hit can stop a vehicle, force a crew to abandon it, block a route, or slow a wider assault. Even when the first strike does not destroy the target, it can break the movement pattern and open the way for follow-up attacks. For Russian units, this means the danger starts before the explosion. It begins when a UAV sees the route, follows the vehicle, and keeps the target inside the kill chain. That is why drone warfare in Ukraine is changing how units move, hide, and decide when to attack. But once accuracy becomes the main weapon, the next question is no longer how large the drone warhead is. The real question is where that warhead lands, because the survival of a heavy vehicle can depend on a single exposed point. Open hatches have become one of the dangerous weak points on Russian armored vehicles. They turn thick armor into a doorway. A tank may be built to resist fragments, machine gun fire, and some direct hits. But that protection is mainly designed to stop a threat from outside. When a small FPV drone enters through an open hatch, the fight changes instantly. The explosive force is no longer pushing against armor. It is now inside the fighting compartment. It is close to crew positions, electronics, fuel vapors, or stored ammunition. That is why a light payload can create damage beyond its size. Tracks are another critical target because mobility is life for a tank under drone observation. A vehicle that keeps moving can still turn, reverse, leave a fire zone, or hide behind trees and buildings. Once the track is broken, that same vehicle becomes a fixed point on a map. It may still have its gun, it may still have armor, but it can no longer decide where the battle happens. For Ukrainian drone teams, that changes the target from difficult to manageable. A stopped tank can be watched, circled, struck again, or handed over to another weapon. The rear of the turret and the area near the ammunition compartment are more dangerous when exposed. Modern armored vehicles carry fuel, shells, propellant charges, rockets, and explosive materials in tight spaces. A small blast does not always need to pierce the strongest armor plate. It only needs to start a fire in the right section, damage a cover, break a seal, or ignite something unstable. When that happens, the first explosion may be small, but the second effect can be massive. Ammunition detonation is not only damage, it is the moment when the vehicle begins destroying itself from within. This is why Ukrainian operators often aim for the geometry of the vehicle rather than its center mass. A direct hit on thick frontal armor may produce smoke and little else. A hit into a gap, a hatch, a rear corner, or a lower side area can produce a different result. The drone does not behave like a traditional shell flying on one fixed path. It can adjust in the final seconds, follow the target, and search for the angle where the armor layout is weakest. Armored personnel carriers, MTLB carriers, and support vehicles are more vulnerable than tanks. They carry troops, supplies, mines, ammunition, or fuel in compartments that are not always sealed like a tank turret. Rear doors, roof openings, side gaps, and cargo spaces can become entry points for a drone or a dropped munition. If the vehicle is parked under trees, hidden beside a road, or moving with a convoy, it may still appear protected from the ground. From above, however, the open layout can become a target. The effect becomes larger when the first vehicle in a convoy is hit. A column depends on spacing, speed, and direction. If the lead vehicle stops, burns, or blocks a narrow road, the vehicles behind it must react in seconds. Some brake, some turn away, others separate and expose their sides. That confusion gives Ukrainian UAVs more time to observe. It also gives FPV pilots more targets to choose from. What began as one accurate strike can become a breakdown across the formation. The entire convoy can become trapped inside a watched kill zone with fewer safe options. Ukraine is not only destroying armor, it is exploiting the design limits that every armored vehicle carries into battle. Hatches, tracks, rear compartments, ammunition areas, and convoy spacing all become weak points once the sky is watching. But as Russia adds cage armor, drone nets, and camouflage around those weak spots, Ukraine must move beyond the single perfect hit and build attacks in connected layers. Ukraine's drone tactics are becoming more dangerous because many attacks no longer depend on a single perfect hit. In many cases, the first FPV drone is sent to damage the outer protection around a Russian vehicle. This can include cage armor, drone nets, camouflage, added plates, or improvised hull frames. These defenses are meant to catch the drone, weaken the blast, or break the attack angle. But once the first strike tears away part of that shield, the vehicle faces the next drone under worse conditions. It is still on the battlefield but no longer protected in the same way. The second FPV often becomes the real danger. After the first impact damages the outer layer, the next operator can aim at the area that has just been exposed. The target may still be moving, but it is usually slower, confused, or turning toward cover. That change in movement can give the next pilot a better chance to hit the turret area, the gun mount, the rear section, or another weakened point. This is why the attack feels less like one strike and more like a sequence. Each drone creates a new condition for the drone that follows. This method also changes the value of Russian anti-drone armor. Cage armor and nets can save a vehicle from one direct hit, and they can force Ukrainian pilots to work harder. But they do not solve the problem if surveillance continues above the target. A protected vehicle that remains visible can be studied, tested, and struck again. Even a strike that does not destroy the target can show where the protection bends, where it breaks, and which direction is easier to attack next. The pressure becomes greater when the target loses mobility. Once a tank or armored personnel carrier is immobilized, the battle shifts from a chase to a controlled attack. Ukrainian drone teams can wait for a better angle, send another FPV, or return later with a bomber drone. At night, bomber drones can be damaging because they do not need to rush. They can hover above a disabled vehicle and drop munitions until fire, secondary explosions, or structural damage make recovery impossible. This matters because battlefield survival is not only about avoiding destruction, it is also about avoiding abandonment. If a damaged vehicle can be pulled back, repaired, and returned to service, the loss is temporary. If drone pressure prevents recovery teams from reaching it, the vehicle becomes a permanent loss. Russia can add armor and send repair crews, but a watched disabled target remains dangerous for everyone who approaches it. Even the recovery route can come under observation before help arrives. Each drone in this layered attack can have a different role. One strips protection, another stops movement. A third searches for the decisive angle. A reconnaissance UAV observes the result and confirms whether another strike is needed. This task division gives Ukraine a way to turn small drones into a coordinated attack package without using a large missile for every target. That is the shift in this part of the war. Armor is not only being hit, it is being processed through a chain of observation, testing, damage, and confirmation. A vehicle may survive the first blast, but survival no longer means safety if it remains inside the watch zone. Once this method proves effective against tanks and APCs, the same logic can begin moving toward targets with even greater value inside Russia's wider war system, where one disabled asset can affect many connected battlefield functions. Ukraine's drone campaign is no longer aimed only at armored vehicles near the front line. It is now reaching into the systems that allow Russia to see, jam, defend, and supply its forces. Radar stations, electronic warfare vehicles, book air defense launchers, fuel trains, and ammunition movements are becoming part of the same target map. This matters because modern combat power does not come from one tank or one gun. It comes from the network behind them. If that network is hit, the front line becomes slower, less protected, and harder to control. Radar and electronic warfare systems are especially valuable targets because they help Russia protect the rear area. Radar gives warning when Ukrainian drones or other aerial threats enter a sector. Electronic warfare tries to cut the control link, confuse navigation, and force drones to miss their targets. When these systems are working, they make every Ukrainian strike more difficult. But when drones locate and damage them, the effect can spread beyond one destroyed vehicle. A gap opens in the protective screen, and other Russian units nearby become more exposed. This is why attacks on systems like Buk matter. A Buk launcher is not a simple truck. It is a mobile air defense platform built to move, hide, and protect troops or equipment from aerial attack. It has more protection and tactical value than many rear-area vehicles. A small FPV may not always destroy it in one hit, especially if the system is moving or protected by electronic warfare. But if the drone damages its mobility, antenna, launcher section, or crew area, the target can lose its main advantage. Once it stops, it becomes easier to follow and harder to save. The same logic applies to Russian logistics. Fuel and ammunition are not as dramatic as tanks in a video, but they decide how long a force can keep fighting. A train carrying fuel or shells can move large quantities quickly through occupied territory. That makes it efficient, but it also makes it dangerous when tracked by drones. One accurate hit on a fuel car can start a fire. A strike near ammunition can trigger a chain reaction. The result is not only a burning rail line, it can mean delayed deliveries, lost stockpiles, blocked routes, and more pressure on Russian transport planning. These strikes also create a psychological and operational burden. If radar teams, air defense crews, and logistics units believe they can be watched deep behind the line, they must move more carefully. They may hide longer, change routes, reduce radio activity, or wait for safer conditions. Each small delay can weaken the tempo of a larger operation. A unit at the front may need fuel, shells, or air defense cover at a certain hour. If that support arrives late, the assault loses momentum. This is the wider meaning of Ukraine's expanding drone target list. The battlefield is no longer divided neatly between frontline combat and rear area safety. When radar, electronic warfare, air defense, and logistics are repeatedly hit, pressure spreads across Russia's entire battlefield system. But not every high-value target can be destroyed by a small FPV alone. That is why Ukraine must connect drones with heavier layers of firepower when the target demands more force at the most critical moment. Some battlefield targets are too hard, too protected, or too valuable for a normal FPV drone to destroy by itself. A small warhead can damage armor, break exposed equipment, or stop movement. But it may not be enough against a hardened radar site, a protected electronic warfare vehicle, or an air defense system positioned under cover. This is where the Reconnaissance UAV becomes more important. It does not only find the target, it keeps the target inside the battle picture until a stronger weapon can be brought in. A reconnaissance UAV can watch the same area for a long period and turn a moving target into a fixed problem for Russian forces. It can track a vehicle as it enters a tree line, confirm whether the crew is still active, and follow any attempt to reposition. More importantly, it can pass coordinates to rocket artillery or other strike units with greater destructive power. In this kind of operation, the drone is not the final weapon. It is the eye that makes the final weapon accurate. Rocket artillery becomes valuable when the target is protected against small drone attacks, but not built to survive a heavier blast. A powerful electronic warfare station may be designed to jam incoming drones. An air defense position may be covered by camouflage and supported by nearby troops. A radar vehicle may be parked carefully to reduce exposure. But once its location is confirmed and tracked, the problem changes. The target no longer needs to be destroyed by an FPV at close range. It can be struck by rockets that carry far more explosive force. Heavier drones can also enter the operation after smaller drones have shaped the target. If an FPV stops a vehicle, damages its mobility, or forces it to remain in a watched area, a larger strike drone or bomber drone can be sent later. This is especially important at night, when recovery is harder and visibility from the ground is weaker. The larger drone can attack with a heavier charge, drop repeated munitions, or finish a target that survived the first stage. The important change is the division of labor. A reconnaissance UAV finds and follows. An FPV tests, damages, or stops. A bomber drone attacks slowly when the target cannot escape. Rocket artillery delivers the heavy blow when the target is too strong for light payloads. Together, these tools create a battlefield system, not a collection of separate strikes. For Russia, this creates a deeper problem. A vehicle or system does not need to be destroyed immediately to be in danger. It only needs to be found, fixed in place, and kept under observation until the right weapon arrives. That coordination forces Russian units to adapt faster, but every new layer of defense also pushes Ukraine to build a more connected and more flexible strike cycle. This is how a small drone becomes the opening move for a larger and faster battlefield decision. Russia is adapting quickly to the growing pressure from Ukrainian drones. Cage armor, drone nets, camouflage positions, night movement, and electronic warfare systems are now appearing across many sectors of the battlefield. Russian crews understand that remaining visible for too long can attract FPV attacks within minutes. As a result, vehicles often move under trees, stop near buildings, or change routes more frequently than before. Some units also add improvised metal structures around tanks and armored vehicles to reduce the effect of incoming drones. These defenses can sometimes reduce the damage from a first strike. A drone may hit the outer cage instead of the turret. A net may force the explosive charge to detonate earlier than intended. Electronic warfare can interrupt radio signals and make drone control more difficult during the final seconds before impact. But the battlefield problem for Russia is that these measures do not fully remove the threat. They mainly force Ukrainian drone operators to change tactics, attack from different directions, or return with repeated strikes that test the same vehicle again. Electronic warfare remains one of the most serious dangers for radio-controlled FPV drones. If the signal is blocked, delayed, or disrupted, the operator can lose control before the drone reaches the target. That is why fiber optic FPV drones are becoming more important for Ukraine. Instead of depending completely on radio communication, these drones use a physical cable connection during flight. This makes them harder to jam and allows operators to keep stable control even inside heavily protected sectors where ordinary FPVs may fail. Ukraine is also expanding another area of drone warfare through high-speed interceptor drones. These systems are designed to destroy incoming Shahed drones and other Russian UAVs before they reach important targets. The goal is no longer only to strike ground vehicles. It is also to challenge Russian drone operations directly in the air. The wider result is a constant race between protection and penetration. Every new defensive system creates pressure for a new attack method. Every successful strike forces changes in movement, camouflage, communication, or battlefield planning. This means the drone war is no longer just about isolated explosions recorded on video. It is becoming part of a larger transformation in how armies observe territory, control movement, protect logistics, and maintain battlefield awareness under permanent aerial surveillance during every phase of combat. The drone war in Ukraine shows a clear change in modern combat. Power no longer comes only from a larger gun, a thicker armor plate, or a heavier missile. It also comes from constant observation, precise timing, and the ability to connect small strikes into a larger battlefield process. Ukraine is turning Russian targets into tracked objects inside a kill chain. A vehicle is seen, followed, slowed, struck, and checked again from above. That process can threaten tanks, radar systems, air defense units, electronic warfare vehicles, and logistics routes that once depended on distance or concealment for protection. Russia still has heavy equipment and deep military resources, but those advantages become weaker when movement itself can reveal danger. The next stage of this war will likely be faster, more accurate, and harder to jam. The decisive question is simple. Who sees first, locks the target faster, and keeps the kill chain alive longer? Please like, subscribe, and follow the channel for more clear analysis on weapons, battlefield tactics, and the geopolitical changes shaping today's world. This content is created for educational purposes about war, peace, military technology, and the global impact of modern conflict. The goal is not to glorify violence, but to help viewers better understand how modern warfare is changing international security and human lives.